Alright, welcome to this particular episode of Solving LeetCode question. Today we are targeting question number 35, which is search insert position. And last time we did question 34, which is fine, and then the time before that, question 33, and we're moving slowly. So this is an easy one. Well, apparently it's marked easy. And I'm guessing it's because the last questions, if you have solved the last two questions, then you have probably used some kind of the solution that you probably use here. And so we are going to read through the question and try to see. It states, given a sorted array of distinct integers and a target value, return the index of the target. Return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write the algorithm in O log of n runtime complexity. Now this has been the highlight for the last three questions, including this one. And apparently, the last time I solved this question, the last question 34, for those of you who watched that video, I used the two-pointer approach, which is not the most optimal approach, although it passed it and ran the entire solution with the test cases, all the test cases at the zero runtime, which was good. But the optimal approach, when you look at it, was a binary search, because the approach I did for the last time, I know I'm taking time for this video, the approach I did for this particular problem, it has a worst case scenario of O of n, if you look at the big O notation. And that's in those cases where the actual, the target is found in the middle of the array. And if we use the same here, we'll have the same problem. So we're going to use, well, it's going to run quite right and it's going to pass, but it will not be meeting this particular requirement, okay? While that approach is very useful and in a lot of test cases very optimal, even in this case very optimal, it is not predictable and it is highly dependent on the array size and the position of the input of the target in the array. So log of n is always constant, it's very predictable, and so on. So this is what we are supposed to solve today. And in this case, if you look at the example, we have input number 1, input norms, 1, 3, 5, 6, and the target is 5, and it says that the output is at index of 2, which is 0, 1, 2. So example 2, the target is 2, the target is not present, the output should be at 1, 0, 1, because after 1 is 2, right? And remember, if it is not found, then we are supposed to return the index in which, if we are supposed to insert this particular target in this norms array, is going to be placed there sorted, right? And 7, same thing at the end. So what we are trying to accomplish here is it's a binary search approach, and we can use that to solve this particular problem, and we're going to see how we are going to do that. Let's look at the constraints. We have the length is between 1 to 10 to the 4th. Each element will carry the number between negative 10 to the 4th to 10 to the 4th. Norms contain distinct values sorted in ascending order from the lowest to the highest, and then the target contains the same as the norm, each of the norms. So the target will always be found within that range. So that is the question, and now we are supposed to solve for the answers. So we're going to get solving here, and in essence we're going to follow what we have been doing. So we're going to compute the length. It's obviously what we're supposed to do of the array, right? We're going to the length will be between 1, which means we're going to have at least one value. So do we need to solve for one value? Not really. So we're not going to solve for that. So we are going to initialize indices. That's the start, the midpoint, and the end. And then we are going to iterate the array. We're going to compare values at mid, start, and end. We are going to increment, and we're going to reassign mid, start, and end accordingly, depending on some if functions here which we'll determine later. And then after, we'll simply just return result if. So return result if it is not. Which is going to be the position, right? Yes. So we can just return result. So first of all, we should start by computing our length. So int length is equals to norms dot length. Remember, it's a property. So we have and then we're going to initialize our indices. So we're going to have start. Int start equals to 0. Int end. Let's say mid. Let's say end is equal to len minus 1. 1, 2, 3, 4. 0 plus 4 is 4 divided by 2, which is 2, 0, 1, 2. Not sure. That's not the midpoint of the 2. Yeah, so we have int mid equal to start plus with start plus len. Yeah, so that will be int mid equals to start plus len plus end divided by 2. Like 2 divided. Oh, okay. Okay, so we have that. Now iterate, it should be while start is less than or equal to end. We want to do something like that. And then, so the idea is that, so for example, the first one is 5. We want to compute the start is 0, the end is len minus 1, which is 4, 0, 1, 0, 1, 2, 3, sorry, 3. And then the mid will be 2, which is no, mid will be 1. Either way, if we have 5 here, which will be 4 divided by 2, which will be 3, then it will be correct. Yes, so the meat will be start plus n, which is 0 plus, is this start plus n? No. Well, start plus n, which is 0 plus, yeah, here will be 0 plus, and n is 3, 0 plus 3 divided by 2, which will be 1, because this only returns 1 down, so 0 1, so this will be the midpoint according to this. And so we are going to check if target is greater than norms mid. So if target is greater than norms mid, then it means that the target is on the top half. So we want to make start to be, start will be equal to mid plus 1, or mid plus plus. Yes. So that will be start mid plus 1, else then it is less than, no, else if my target is less than, target is less than norms mid, then okay, so target is less than equals to norms mid, then if that's the case, then the lower half, then we want to put end, which would be right or left. N is equals to mid minus 1. Yes. Else, then the target is equal to that. Else, then we just return mid, right? We compute mid. Yeah, so we'll just define mid here and we compute it each time we are running the array. So we'll just define it and then we'll compute it here. Yeah, so it will be mid each time we'll be doing that. So excuse me, the first time it's going to choose this as the mid, no, this as the mid, and then it's going to realize that mid is not there. It's going to take this and this, and it will be start plus n, which is not correct. I don't think it's correct. Let me see, start plus n. What's start here? 0 1 2, which is 2 plus n, which is in this case to be 2 plus n, which in this case is 3, 0 1 2 3, which is 5 divided by 2, which is 2, 0, 1, 2, and that will be the mid. Right. But what if it was 5? Then it will be, so that will be the mid, so that will be 2. So its target gets the mid. So it was like say 4. Yes, let's say 4. So its target greater than mid, say yes. So we're going to put mid to 1. So lower is equal to that. So it will be, so the mid will be 4 plus 4 divided by 2. So it will be 3 plus 3 divided by 2, which is 3. 0, 1, 2, 3. 3 plus 3, yes, divided by 2, which is 3. And the mid will be 3. So you're going to check its mid is equal to 3. So eventually we zero in on a particular number. Yeah, you zero in on that number. So I'm saying what I'm trying to look for is that we have, say we have something like this, like we have that, right? And then the target is, say, is 4. I just put 4, right? Target is 4. So the first time is going to cut this first half and it's going to put here, is this greater than that? Is target greater or equal to that? No, it's going to 0 back in here. So the first time is going to cut this part out because yes, target is greater than 3. So it's going to cut that part out and initialize that. And then it's going to ask, is target greater than norms mid? Norms mid, and they will be the new mid, obviously. Norms mid, no. So if that's not mid, then it will be start, it will be equal to, it is no, so it's not going to go. Is target greater? Is target less than norms mid? Yes. So it's going to put n equals to mid minus 1, which is end mid minus 1, which is 3. Which is interesting. Yeah, that's 3 because so the first time it's going to calculate mid as start plus n, which is 0 plus 3 divided by 2, which is 1. So it's going to take this, so this will be the mid. It's going to check this, that's it's not, yes, this will be true, and we're going to put start as mid plus 1, which is going to be 5 and 6. That will be left. Then it's going to come and say, what's the new mid? The mid will be 5, which is 0, 1, 2. 2 plus 3, which is 5, divided by 2, which is 2, 0, 1, 2. And you're going to check, is target greater than norms? No. Is target less than norms? Yes. And it's going to put n equals to mid plus 1. So mid is 2 minus 1, which is 3. Right? So at this point, start is no longer, so it's just going to exit, and start is no longer greater than. So there's a problem there. There's a problem there. So in this case, say if the target was 4, what we're no longer looking for a particular number. We are looking for the position where we're going to put this number. However, we'll find ourselves at the second iteration with our end here and our start here. And at this point, you see that this does no longer go. And So we can do, so we'll find ourselves with our end, our start crossing each other, which will defeat this purpose. And so we can have if, so so in that particular case, you can put if target is greater than, so our n, our start, so n becomes less than, if target is greater than n, so norms of n, right? So yeah, so target greater than norms n. Again, remember we are returning an index. We have to return an index either way. So when we are at this stage, it means that we have not found the value, the target value, and we're trying to return an index. So we'll get to a point where I think they'll crisscross, right? Yeah. So how about and target? So target is greater than norms n, right? So is it less than, if target is greater than norms n and target is less than or equals to norms start, right? So essentially we are asking, so when the n is here, the start is here, right? We're asking if the target is greater than this and it's less than this. If that's the case, then return norms, so return start, because we want to put it after this, we want to put it after the end, so return start. Else, if target is less than start, else if target, let's say, less than norms n, right? So if we are here and the target is less than norms n, then we want to put well, yeah, because that will be the mid. We'll start, so that will be the start and that will also be the mid, and this will be the end. The end will now become this, and this will still be the start and the mid. This will now be the end. I don't think that these other ones work here, but let's just, I think this is like redundant check, because here, I don't think this will ever be true. That's target less than or equals to norm start. Right? I don't think this will ever be true. Norms end. That will never be true. But the target can also be equal to that, then that will also be true. If it is greater than that, because this is the mid, this is also the start, so it's 2, this will be mid, this is the start. So what if we have 7 here and we have to close 6? And this will be this will be the mid, so the start. So you're going to check mid norm. They were looking for 6. They'll have start mid plus 1. You know what? Let's check. You can just don't start here. Because okay, let's run through manual scenario. Right, so we initialize the start 0, the n is negative, is 1, 2, 3, so it will be 3, and then the mid will be, so when we iterate, the mid will be start, which is 0, plus n, which is 3, divided by 2, which is 1, so 0, 1, that will be the mid, and then it's going to check if target is greater than or equals to mid, and target here is 5. You know what, we want to put 7 here, right, and rather I want to omit 6 there. Okay, and our target should be 6. Let's put 6 there. So we're going to run these two simultaneously. So the first say is target 6. Is it greater than equals to mid? Yes. So it's going to put start equals to mid plus 1, and our mid is 3 here, plus 1. So our mid index is 0, 1, so plus 1 will be 2, giving it our mid to start at 5. So our new start will start at 5, and then it will keep the n to still be at this n. So we'll have this 2, and it's going to come here and it's going to ask mid is equal to start, which is now at 0, 1, 2, plus n 3. So 2 plus 3, which is equals to 5, divided by 2 equals to 2. So 0, 1, 2, this will be our mid, right? That's what it's saying. And we're going to ask if target is greater than or equals to mid. Yes, target is greater than or equals to mid. We're going to start equals to mid plus 1. So target is 6, greater than or equals to mid. Mid is equals to mid plus 1. So start is equals to mid plus 1, and that's 7, right? And now we have our n 7, our mid 7, our start 7, because it's going to be 1 plus 1 equals to 2, divided by 2 equals to 1, so our mid is going to be 7 there. So everything is equal to 7, and we're going to check is it greater? No. It's going to check is it less than? Yes, and mid is going to be mid minus 1, which is this index here, which is 3 minus 1, which is 2, is going to get back this 2. And now we are going to at this point in time, our end is greater than our start. So our start is less than our end. So why our end is less than our start. So our start now becomes greater than our end, which now pops out of this equation. Now we have to put 6 in between. So we are checking. So it will be start So if we just return start there, these two will pass. Right, these two will pass. This one will definitely pass since it's already checking. If we had 4 here, that will pass. If we just return start, if we're supposed to put it, then it will be here, which is going to be at this point. Start is equals to 0, 1, 2, 3. Start is at 3, and so that will be 0, 1, 2 plus 6, which is 3. Yeah, if we just return start there, then it will be 3. You know what, let's try and run it and see if that passes this initial test case. There's some error, so we have that. What's it saying? Target. Okay. Time exceeded, so we have an infinite loop. 1, 2, 3, 4, 5. Oh, we have forgotten to increment our start, our plus. But we do increment our start, our plus. That doesn't make sense. So let's check that again. It says time exceeded, so I'm guessing we are in a loop and we are not doing something. Say while start is less than or equals to end. So the first time we're going to calculate mid, and it's going to be 1. So it's going to be take this one, and then we're going to check if target is greater than or equals to. So target is greater than norms mid. Yes, which is 5. Target is 5 here. Yes. The one we will start is mid plus 1, which is plus 1 there. There'll be a new start, and then we compute mid to be start plus end divided by 2, and then we check if target is greater than or equals to mid. If target is greater than mid, no. Target is less than mid, no. And return, else return mid. That was supposed to, yeah, I don't know. I'm not sure why it's exceeding. It's exceeding. It's supposed to return here. Yeah, so I think that something is not submitted too frequently. That's not correct. It's either I'm having some issues. Yeah, time limit exceeded. So we will compute mid every time, and we're returning here. This is supposed to return, so we should just system dot out dot print ln, right? We just do the mid plus mid, right? So we want to print out mid, and we see how many times that runs. Yeah, so it goes mid is 1, which is weird. It's not supposed to be. I don't think we're supposed to. Okay, yeah, mid is 1, sorry. Yes. Mid is 1 for the first time, and they have like an infinite loop there. So 0, 1, yeah, that's mid. the mid equals to start now becomes mid plus 1, which is and 2 as a start 2, and then the end is len minus 3, which is len minus 1, which is 3. Start plus n minus divided by 2. I don't know if it is the mathematics that's the problem here. It doesn't make sense. Yeah, okay, yeah, it was a math. Yeah, it was a math. So when I left it like that, what happened is it took start plus n. So if I think it did a division first before the addition. I think if you put board mass, yes, board mass division first or addition. So we'll put it like this. It's better. And that was what was a bit confusing for me. So you have expectation 2 for the first one, but I don't know if this will actually work when we submit it. It does work actually. Okay, that was easy, as it should be. Because I was wondering about this returning the start, but I guess my assumption was right, because you see, when n crosses the start, we don't care about. What happens is that the start is always greater than the n at the end when it gets to this point, right? So the target value, so is always greater than where the value where the n will be indicating, and so the start is a perfect place to have it there. So that's good. Yes, so that's a good one. So we have okay, so that's the solution. That wasn't so bad. I thought it would be a little bit complicated, one of those easy ones that get really complicated, but this was good. This was easy. Yes, easy, right? And yeah, I think this is I think we also managed to solve for this, right? The log. The time complexity, though I don't know how to check. Yeah, since it's a binary search, it makes sense. So we made the time complexity. I feel like we did. Anyway, if you like this video, like, subscribe to the channel and click the notification bell for when I upload newer videos. We'll have some new series coming up where we're doing architectural designs and other software engineering, very interesting stuff. But for this LeetCode session, I think that's all for today. There was an easy one, and I hope the explanation was as simple as that, and I hope you get to see how the software engineer get to think about problems. It's not all straightforward, and we all know. As you can see, I struggled here and I had to do some manual calculations and even guesswork sometimes even try and error, right? In this case, it worked out quite smoothly. In other cases, it would take longer. For those of you who have been following the channel, following the videos, you see other videos are hours longer. So yeah, it's not a straightforward line. That's a reality of solving problems. It's not always as it's not glamorous as the movies try to show, and maybe some people even try to show on YouTube, like you come and you learn. Those things are already rehearsed. This one is just straight. We solve questions as we go. We face the problem and we see the unfiltered errors that I make, how stupid I can get, how intelligent one can get doing solving this problem. So even an easy problem like this can cause you a lot of headache. For those who have been here, you have seen us struggle an hour or more on easy problems. So it's not always this smooth, but today it was a great one. So share the video, like, comment your thoughts below, comment your approach that you will use. This was an easy one. The solution is simple and straightforward. And thank you for watching. Until next time, stay safe and stay blessed. Goodbye.